Thanks, Tom. Thanks, Shannon. As Tom said, my name is Jim Querry, and I direct a small graduate program in geodesign at Philadelphia University. What I'd like to do is to go over with you, share with you today a small but very important workflow. And this has to do with generating design content, site design content, as well as a proposed terrain known to the landscape architects, the engineers in the room, as a grading plan, and then converting this to GIS, modeling it in CityEngine, and sharing it out via the web. So our core values in the program are around collaboration. We collaborate across the college with architecture and landscape architecture, sustainable design, interior design, and construction management. Our programs are very innovative, and sustainable design is a big value for us, but also client-based studios. So our studio and our project this year is Philadelphia Navy Yard. This is part of the BRAC system in the 90s, the base realignment and closure. And this was acquired by the city of Philadelphia in the mid-90s and is being redeveloped. The client is the Industrial Development Corporation, Liberty Properties, who is the developer. Site is the Navy Yard. Photo on the left is the battleship New Jersey being launched in 1942. That battleship is now retired. It's on display across the river, ironically in New Jersey. And you can visit that if you visit Philadelphia. If you do visit Philadelphia, also stop into Urban Outfitters. It's their world headquarters. They are the largest occupant of the Navy Yard. They employ about 3,000 people here. Photo on the right is their cafeteria, and it's an incredible space and a lot of energy, a lot of design energy there. So here's the Navy Yard. This is a master plan that was done by Robert A.M. Stern, Michael Van Valkenburg in 2013. It's about 1,300 acres, same size as Center City, Philadelphia. The section that we're going to focus on is Muston Park for this presentation. And again, this is a very intense and focused workflow, and it is about site design content. And the challenge that we're trying to, or the problem that we're trying to solve here is how do you develop rich design content at the site scale, the district scale, including proposed terrains, and then bring it into ArcGIS and CityEngine so that everything matches up just right. So this is Muston Park. This is the beginning of our model. The first thing we want to do is model the master plan and then work from there. So this, we're interested in those spaces, as Jan Giel would say, the life between the buildings. So we're today going to focus on pretty much one thing, and that's just a parking area. I just wanted to use that for a demonstration. Here's a model that our students did last summer, and everything looks like it fits. First finished floor elevation is about 24 inches above the 100-year floodplain, and things seem like they're pretty good, but when you actually get down and look at it at ground level, some of those features don't fit. We have, it's not supposed to be an elevated walkway, it's supposed to fit on the terrain. Those things in the foreground are actually parking spaces and islands and striping and all of that stuff. So, collaborators. The principal architect for this is Patrick Hagen. He is an Esri employee out in New York City, Lower Manhattan actually, and he is also an adjunct for us at Philadelphia University in the Geodesign program. And also Steve Lewis and Mike Kissinger with Pannoni Associates, an engineering firm in Philadelphia. They have done a lot of work in the Navy Yard, and through this process have pretty much discovered CityEngine. SiteOps is an online cloud-based solution that we have used to generate site content. And the workflow is pretty much designing in that environment, grading in that environment, exporting out to ArcGIS, into CityEngine, and out to the web. So, SiteOps, cloud solution, site-by-site design, we mean things like parking and circulation and that type of thing for this presentation. Site engineering, again, grading plan, and then exporting via land XML and DWG. Okay, so let's take a look and see what this looks like. Where is it? There. So here we are at Muston Park. And this is just a small section of the site, but we're going to go ahead and develop a parking lot. This parking lot is going to generate about 1,400 spaces initially. Sorry, there we go. There's our parking lot. Come over here and set some parameters. So it's the width of the space, the length of the space, the width of the aisle, angle of the parking, some grading parameters, 1% minimum, 4% maximum. We do that, come up, hit the solver button here, and it generates about 1,400 spaces. Those are dynamically linked, so they're all one object, one intelligent object, and when you change the boundary of that, it dynamically reconfigures your content. So here we're just changing the outline of it and so on. So the next thing we want to do is go in and create a building, move that building into the parking, and you can see everything starting to respond to that. Okay, you get the idea. So now we're going to come and look at grading. Once you arrived at a site design, then you need to grade that so that you have a terrain that responds to those design elements. The grading part of this is done, although we're seeing contours here, it's actually, when you look under the hood, it's a tin, triangulated irregular network. And it has an interesting component here where you've set parameters ahead of time, including unit cost parameters. So as it's going through this, it is trying to optimize grading. It's trying to balance cut and fill. It's trying to minimize excavation on the site, moving earth or material around, and at the same time give you a readout of paving, curb, sidewalk, that type of thing. So it's a pretty good example of a site design content generator. So now we're going to export out of this via Civil 3D file, DWG file, the line and polygon features of this parking lot, and also via land XML, the terrain. So I am going to skip right to the ArcGIS Desktop. So we want to bring this data now that we've generated this design content into ArcGIS, create a database, geodatabase, import the design content into the geodatabase, add attributes, assign projection, all that stuff that we're used to doing, prep it for CityEngine. So here we are. Over here, we're going to select that DWG file and bring it into our map, see the features, and then start to configure these features. So what we need to do is we need to create these features and the data tables according to accepted standards. We are going to accelerate this process. As we're creating feature classes, we're also going to create the fields and populate those fields with values. The thing I skipped over here was a model that actually does the feature conversion. Okay, so the idea is to automate this and make it reusable. So not only can we do it for this project, but we can do it for any project. Okay, now CityEngine, we want to bring the data into CityEngine and visualize it, see it in 3D, clear representation of the design, and then generate reports. We want to be able to measure the success according to our sustainability measures. So here is our CityEngine model, and we've already started to bring in some of the content. So these are the 3D buildings, some of them existing, some of them proposed. For Muston Park, these are proposed. We import the geodatabase. We're going to go in and select these features that were exported from SiteOps in the geodatabase and go down to parking. Now you can see the features start to appear. So the These are actual landscape features. They're sitting on a terrain. That terrain, again, is a proposed terrain, so the idea is that these would fit pretty well. However, we're seeing that in some cases they don't. So the large, expansive paved areas don't quite fit that landscape yet. So what we need to do is to subdivide them. So we have a rule set here that we're applying to the parking lot and get it to the point where it is almost there. It's almost fitting the landscape, but there are a few things, or the terrain, I should say, few things that aren't working. And so now we're going to go in and apply, select all of those objects. We're going to apply a different rule set, a subdivision rule set. We're going to set our parameters at 2 meters by 2 meters. So we're going to cut this up into 2 by 2 meter sections, and then we're going to convert those models to features, to shapes, I mean, and then we're going to fit those shapes to that new terrain. So if we're successful here, and I know we will be because it's a video, then all of these things are going to fit on there perfectly, and then we can move on to other parts of the design. So you can see that terrain start to appear here. You can see those parking islands. We'll see in a second trees and striping and driving aisles and that type of thing. It's our pavement start rule. And voila, there they are. Everything sits exactly where it's supposed to, and we actually have features and not a aerial photo draped over top of an existing landscape or existing terrain. So that's it. We then, of course, upload it to a web scene and then share it out with the stakeholders and our other collaborators. This is the web scene. If anyone has any questions, you can get a hold of me at that email address. Thank you.
Thank you, Jim. Thank you. Good job.
Thanks.